say you see this kind of a simple question in your chemistry JAMB exam. How will you solve it? It is very simple. Let us solve it together. The question says the bond formed between H2O, which is water, and H plus, which is hydrogen ion, to form H3O plus, which is also known as hydronium ion, is. So this is a very simple question, and this is a type of question that deals with chemical combination or chemical bonding in chemistry. So now let us explore our options. The first option we have here is ionic bonding. What is ionic bonding? Ionic bonding is a type of a bonding whereby electrons are completely transferred between the participating atoms, probably 2 participating atoms or 3 participating atoms. In this particular type of a bonding, electrons are completely transferred. Now, let me give you an example of an ionic compound. An example of an ionic compound is sodium chloride. That is our normal salt. Sodium chloride or even magnesium chloride, yeah, MgCl2 is also an ionic compound. So let me explain why it is an ionic compound. Let us use sodium chloride as our example. What is the atomic number of sodium? Correct. The atomic number of sodium is 11. The atomic number of sodium is 11. There is something I also want you guys to note. We should know that bonding is a chemical property of an element. Yes? So you should know that electrons take part in bonding. If you hear bonding, the first thing that should come to your mind is electrons. So electrons are responsible for bonding. And what is the aim of bonding? The aim of bonding is to attain stability. You know, for elements to attain duplet or octet, for them to be complete, for them to have a completely filled shell. That is the aim of bonding. So now let us go back to our sodium. The atomic number of sodium is 11 and the atomic number of chlorine is 17, right? That means that sodium has 11 electrons and chlorine has 17 electrons. So let us try to write the electronic configuration of sodium and chlorine. The electronic configuration of sodium and chlorine is going to have 2. For sodium, it's going to have 2 in its first shell, while the second shell is going to have 8, and the next shell is going to have how many? 1, right? 2 plus 8 plus 1 will give you 11. So that means sodium has 2, 8, 1. In the first shell, it has 2 electrons. Second shell, it has 8 electrons. And the last shell, it has 1 electron. For chlorine, it has 17 electrons, right? In the first shell, it will have how many electrons? 2 electrons, right? In the second shell, it will have 8. And in the third shell, it will have how many? Correct. It will have 7. 2 plus 8 is 10. 10 plus 7 is 17. So, now when you talk about bonding, bonding deals with the valence shell and valence electron. I'm talking about valence shell. When I talk about valence shell, I mean the outermost shell. The outermost shell is what we call the valence shell. And when we talk about the valence electrons, we talk about the outermost electrons, the electrons that are in the valence shell. So in this particular electronic configuration, which of these electrons are the valence electrons? Yes, for sodium, it has 1 valence electron, and for chlorine, it has 7 valence electrons. So for these 2 atoms to form sodium chloride, they need to combine. So let me try to draw the diagrammatic representation of both sodium and chlorine to show you the combination. For sodium, let us say this is the first shell. It has 2 electrons, right? And the second shell, it has 8 electrons. Let's try to draw it, right? 8 electrons. And the last shell, it has 1 electron, right? And it wants to combine with chlorine. Chlorine with 17 electrons. The first shell has 2 electrons. The second shell has 8 electrons, which I'm drawing. And the last shell has 7 electrons, right? 1, 2, 3, 4, 5, 6, 7. So now, as you can see, this particular sodium, it wants to attain octet. That means it wants to have 8 valence electrons. And also, chlorine also wants to attain octet. That means it wants to have 8 valence electrons as well. Now, the valence shell of sodium has only 1 electron. The valence shell of chlorine has 7 electrons. So, this sodium can just transfer this 1 electron to chlorine so that they can become sodium chloride. So now, our sodium, which was supposed to be 281, will now turn to 28 because it will lose this 1 electron, or it will completely transfer it to chlorine. And if it transfers it to chlorine, chlorine will then have 1 more electron here, which will make chlorine attain octets. And then chlorine will now become something like 288. You understand? So both of them, they have achieved their aim. because they are both now stable. You understand? So that is basically the simple explanation of ionic bonding. Ionic bonding deals with total transfer of electron from one atom to another to attain stability. Now let us move to the second option, which is covalent bonding. Before then, if you want more practice questions, don't forget to download the Class54 app on Play Store or App Store, because we have numerous and unlimited past questions which you can use to practice and ace your JAMB exam. So let us continue. What is covalent bonding? Covalent bonding is a type of a bonding whereby electrons are shared between the participating atoms. Most times it could be shared equally between these participating atoms. So now let me give you an example, or let me give you examples of covalent compound. An example of a covalent compound is oxygen gas. Also, hydrogen gas is also an example of a covalent compound. Even methane, which is CH4, is an example of a covalent compound. Let me use oxygen or hydrogen gas to show you how covalent compounds work. I told you that covalent bonding is a type of a bonding where electrons are completely shared between the two participating atoms. Now, let us use hydrogen gas as an example. We all know that the atomic number of hydrogen is what? Is 1. That means that hydrogen, we have one valence electron. So let us try to draw the diagrammatic representation. So this is hydrogen atom, and this is another hydrogen atom. So these are two hydrogen atoms. They want to combine to form hydrogen gas. You know, they want to attain duplets. That means they want to have two electrons in their valence shell. You know that hydrogen only has one shell. That means it just needs two valence electrons to be stable. So these particular two atoms of hydrogen are going to combine together, sharing their electrons. Something like this. We are now going to have something like this. You see? So you can see that they are sharing one electron each, and they are both donating these electrons to attain hydrogen gas. So I believe this is very simple to understand. Let us move to the next option. The next option is electrovalent bonding. Don't get confused. Electrovalent bonding is another name for ionic bonding. Electrovalent bonding is another name for ionic bonding, which I explained earlier that ionic bonding or electrovalent bonding is a type of a bonding where electrons are completely transferred from one atom to another. So let us move to our last option, which is dative or coordinate covalent bonding. You understand? So what is dative or coordinate covalent bonding? This is a type of a bonding whereby electrons are shared between two or more participating atoms, but these electrons that are shared are only donated by one of the participating atoms. It is not like covalent bonding whereby they are sharing equally and they are both donating. You understand? In coordinate covalent bonding, they are sharing, but it is only one person that is donating, or it is only one atom that is donating the electrons that both of the participating atoms will enjoy together. So this dative or coordinate covalent bonding is also an example of covalent bonding. It is just the coordinate covalent type of bonding. So let me give you an example. An example of a dative or coordinate covalent compound is ammonium ion, that is NH4 plus, NH4 plus. Also, another example is H3O plus, which is our hydronium ion. So now let me try to explain this thing the simplest way that you can understand. Let us use hydronium ion as our example. Don't forget that hydronium ion is formed when H2O, which is water, reacts with hydrogen ion. So now let us try to draw the diagrammatic representation of both H2O and hydrogen ion showing their electrons. So now for water, we know water is formed from two hydrogen atoms and one oxygen atom. And we all know that the atomic number of hydrogen is 1. So the atomic number of oxygen is what? Atomic number of oxygen is 8, right? So now what is the electronic configuration of oxygen? We know that it's 2, 6, right? It has 2 electrons in its first shell and it has 6 electrons in its valence shell. So let us try to draw H2O showing its electrons or the bonding formation of H2O. So now let us draw oxygen. We all know that oxygen has 2 electrons in its first shell, and in its valence shell it has 6 electrons, right? 1, 2, 3, 4, 5, 6. So this is oxygen, right? This is oxygen. And it wants to combine with 2 atoms of hydrogen, right? So we all know that hydrogen has only 1 valence electron, right? So if they combine, these 2 hydrogen atoms will have to come to meet oxygen atom so that they can form water. And that way, you are going to have something like this. This is the first shell of oxygen, and this is the second shell. This is two, two, two. I remember this place is only one, this place is only one. So this hydrogen is going to come to this one, and this hydrogen is going to come here. So we are going to have something like this. You see, I'm trying to draw water molecule for you guys to see. So these hydrogen atoms, they have come to this place to combine with this oxygen atom to form this. Can you see this combination? They donated one electron to oxygen. This hydrogen donated one electron and this donated one electron to form water. Who can tell me what type of a bonding is this? This is purely a covalent bonding because they are sharing. Remember, we are still going to our dative covalent bonding, which is the reaction between water and hydrogen ion. So now, this is our water, right? Now, what is hydrogen ion? H plus. In chemistry, when you see anything like plus on something, that means it has lost an electron, right? It has lost one electron. If you see something like Na plus, that means sodium atom has lost one electron, right? So if you see something like H plus, that means hydrogen atom has lost one electron. You understand? If you see something like Cl minus, that means chlorine atom has gained one electron. I hope you get it. So now H plus, this is H plus. We all know that hydrogen is supposed to have one electron in its valence shell, right? But don't forget that it has H plus. That means it has lost the one electron that it has. So it will have no electron. Yes, are you following me? So it will have no electron. And so this hydrogen ion, which is H plus, wants to combine with water, with this water, to form hydronium ion. Don't forget that I told you that dative bonding is a type of a bonding whereby two atoms share electrons together, but the electrons that are shared are only donated by one of the participating atoms. So now, this hydrogen ion will come to join water. You know, water has two lone pairs. That means two pairs of electrons that are not taking part in any bonding. Water has two lone pairs. You understand? So this hydrogen ion can just come to join this water molecule and share these two electrons with the water molecule without even donating anything. You understand? So as we all know, this is our normal water molecule. Let me try to draw it. Two electrons in this place, and then here it has two joined with hydrogen ion, two here joined with hydrogen ion, and then it has two lone pairs, which is this and this. And so this hydrogen ion will come to join this, to come and share the electrons with H2O, that's with water. So we now have something like this. Plus, that means that this hydrogen ion is not bringing any electron to the bonding. It is just taking advantage of the electrons that are in water originally. So this is how H3O plus is formed, which is hydronium ion. So our answer to this question is dative or coordinate covalent bonding. And examples of compounds that have this dative or coordinate covalent bonding is we have ammonium ion, which is NH4 plus, and hydronium ion, which is H3O plus. There are more compounds that have coordinate covalent bonding. If you want to practice more, don't forget to download the Class54 app on App Store or Play Store. And I will see you guys in the next one. You can also drop your questions in the comment section.